Hello, my name is Mario. Welcome to another Learning Go video. In today's episode, I'm going to be starting a series covering specifically how to access relational databases in Go. So, let's go. As usual, the link to this example will be in the description of this video. It will show the actual final implementation. What I have right here is your typical, use an empty Go module that doesn't have anything outside of the minimum requirements in the standard library. What we're going to be doing is we're going to be using the database SQL package, and specifically one of the drivers for accessing PostgreSQL. You can use PostgreSQL with Docker, or maybe you can install it, your typical package manager if you're using Linux, or maybe you can download the actual binary, the executable, if you're using Windows, whatever you like doing it. Now, what I'm going to be doing in future episodes is I'm going to be covering also MySQL. For this specific one is only Postgres. Now, Go in the standard library does not provide a package for any database. So what it provides though is a way to access multiple databases that happen to be implementing the API that the Go standard library define. Now, first thing first, we're going to be using this package, like I said, PGX, or maybe they didn't say that before, but PGX is most recent. It's one of the most supported packages for PostgreSQL. Typically, what you see online will be using libpq, but that one is not maintained that much anymore. So, highly encourage you, if you're using Postgres, to use PGX instead. PGX supports the database SQL API as well as its own that I will be covering in future episodes. In order to use this package, you will have to download the module. And in order to download the module, you will have to initialize a module. If you're not familiar with modules, I highly encourage to look at the video that I recorded previously. I will be leaving the link in the description. So what we're going to be doing first, we're going to be downloading the module. And if you notice now, is my Go mod now includes all those files, or rather all those packages. One important thing about PGX is that by default you will be using the PGX implementation of, or rather, you will not be able to database SQL unless you import the stdlib package. So what we're going to be doing here in main.go is we're going to be doing an import, the same, the path that we defined before for the Go module, and stdlib, and we're going to be doing an empty import. And what this does is it initializes the package that we need for accessing the database in Postgres. Now, obviously we need to run our Docker container, because I said I want to be running Docker. So I have this fancy just copy and paste instruction that I will showing you, that I will be showing you right here. So I have my Docker container that is going to be using Postgres 12.5. The database name is dbname, the password is password, the user is user. All of this is important because when we're connecting to the database, we need to indicate all these fields. So I have my Docker container running right there. If I do a docker ps, it will show as usual. So I'm going to be opening another terminal, and I'm going to be 2021 11 17, and what we're going to be doing here, I'm going to be using this one for running the binary for the demonstration, and this one, what is going to be happening, I'm going to be doing an interactive exec, the name of the container that I'm running, psql user, and the db name. And this is for showing you the different what the heck happened. Exec I moved the parameters. So exec it, so on and so forth. So with this, what I'm going to be showing you is a way to access the values that I have in the database. You can use Table Plus if you are using Mac OS. Maybe you can use pgadmin, or if you're on Windows, you can use a client for accessing Postgres. It's a simple way to get the data directly from the actual database without using a GUI. You can use whatever you want, basically, what I'm trying to say. Now, how can we connect to PostgreSQL? And this is one of the important things to have, is that when you're dealing with specifically databases, typically what you have is use a string that indicates the DSN, which will be the data source name that describes the details about the connection that we're going to be using for connecting to the database. The way that I like doing it is defining the DSN, but typically, and this depends on the driver, typically what you're going to be doing is using a string, but in this case, again, in this case of this driver, we're going to be using is the schema URL. Let me open this, or rather save it so we can get auto completion. So the DSN will allow us to define a sort of like a schema using Postgres. So we have scheme Postgres, and we're going to be defining the host, which will be localhost, because that's what we're running, 305432. If you remember, that was the port that I used for exporting my Docker container, which is actually right here. And next will be the actual user. So user will be user URL, user password. It will be user. If you remember, again, I'm going to scroll up a little bit so you can see it. So I have user is user and password is password. So we have user password, and next will be a path that indicates the database name, which will be db.name. So now that I have here this, I need to indicate specifically to Postgres, I need to indicate if we're using a SSL mode. In that case, we can use the query program to get the data, and then add this SSL mode disable. And with that, what we're going to be doing is DSN raw query Q encode. And now, if you're familiar with the not the net HTTP, but rather the net URL package, you will notice that we're using this type to create a URL that we're going to be passing in to the sql.Open function, and you will see that in a moment. So with this, we can actually take the data that we need and actually, or rather the configuration that we need, and start connecting to our database. So the first thing that we're going to be doing is calling database sql.Open, and what open receives first, if you notice, is that it actually, if you look at the documentation that I have here on the screen, it will be receiving the driver name and the data source name. The driver name will be pgx, which is the package that we're importing right here, and the actual DSN will be DSN string. And with this, if you remember, what Open is doing is returns a database, which is not an actual database connection, but rather a pool of connections. And that is one of the confusing things in the beginning when dealing with databases in Go. So we're going to be generating a DB and an error. And we close this one. And as usual, if error is different than nil, we're going to be doing fmp println sql.Open an error and return, and we save it, and everything seems to be working. Now the thing with this is that when you open a database or a pool of databases, or a pool of connections rather, you need to close those. So we are going to be closing them. We not defer, so defer function, and we're going to be calling the method for closing the functions in db. So I'm going to be printing out a message so you know that it's closed for context. So I'm using println instead of using, for example, log of fatal f or fatal ln, because when you're calling fatal l, it will call os exit, and defer will not be called when you're calling os.exit. That's something that you need to consider. Now, with this in place, what we are going to be doing is that we can take and actually do something about the database. So we can create a table that we're going to be using. If we go and again, I have my pSQL right here, and I'm going to be taking another instruction for creating a database. We can create a table called users, and then users will have a name, varchar not null, a birth year, followed by some configuration. It will be a small int, null, default 0. I mean, you can literally do whatever you want, but for this example, we are creating a table. So with this in place, what we can do is actually use one of the instructions for inserting a value. Let's insert a value. Let's go insert into users, and we have name, birth year, oopsie, values. The name will be, me, and then let's say 1900. And now we have a user and with a birth year. Okay, so that's more than enough. What are we going to be doing next is we're going to be accessing the value using a method called query. Now, one of the things that happened in, I don't recall exactly, I think is when context was introduced, some of the functions, rather the methods and some of the functions as well in the standard library started adding the context as one of the arguments in new functions. And if you haven't seen the video that where I was discussing context, I will be leaving the link in the description as well, so you can check that out. But basically, we're going to be using all the context-like methods in DB for interacting with our database. Context is used for cancellation, error propagation, and also for adding key values that happen to be passed down into multiple layers in our program. Specifically for this one, we're going to be using QueryRow that only returns a row that we want to. So we're going to be doing QueryRow select from users where name equals, well, Mario. So we have a row, error, and typically we need to close these quotes, and as usual, println db.QueryContext if there was an error, and I return. And finally, what I want to be doing with the way it works, we need to scan the values, which is, okay, we get a result from the database, we need to get that data into some sort of variable that Go can understand, and then we can do something with those values. In this case, I rather, instead of using select the star, we're going to be using birth year. And for birth year, we're going to be using a type of int64. The way it works in Go is you need to scan the values. So you get a row, and then if you notice is so let me save this one. So we have birth year, query context, and then row will be printing out a scan, and we can do a birth year, and that one will also return an error if something wrong happened. So we have error, we assign it, and again, if error is different than nil, your typical error handler in Go. And finally, we print ln the birth year in Go. So we print it out, and everything should be compiling as usual. So mismatch variables. Oh, of course. So row actually return only query row context only returns a row. So what's happening is that row has an error function method that returns an error if something went wrong. So we're going to be doing this, and after that we can actually call a scan. So with that, if we run our binary, you will see the actual, oh, of course, remember I was using context, so I need to pass in the context background. So with that, I can run it, and it should be okay because I got birth year and then closed. All right. So, but there is a gotcha with this one. Let me show you something. So the assumption right here is that we have a server running, and actually we do, right? We have our server running right here, but most of the times we need to check if that actual connection is available. So what I'm going to be doing is I'm going to be stopping this for now, and I'm going to show you what happens when you try to run the same program without actually doing something, which is one of the gotchas when trying to access relational databases, and that will be calling ping before you actually access or execute any command. What happens here is that sql.Open doesn't actually connect to any database. Remember, it's a pool of connections. What typically happens, and depends on the driver, is what it does is that it checks the DSN and it makes sure that the actual value is correct, and it fails if it isn't. So what we need to do here is we need to do a db.PingContext, which will be, again, using the default context, it will return an error And if error is different than nil, we need to just copy paste this thing, put it up here, return, and move on. So PingContext, if I run the same command, you will notice that now it's going to be telling me, hey, there was an error with the PingContext, or rather PingContext fail. You cannot connect to the database. That's it. So if we start our previous server, we start the container, it runs, I can actually run it again, and it will work as expected. So that's really cool. So something to keep in mind when you are dealing with connections in Go. And again, it depends. There is a way to actually access a connection after you open. I will cover that in a future episode. So we have this. We can now move on to the next command that is applicable to when accessing databases. That will be actually inserting records into the database. And that one will be a method called ExecContent. And ExecContext will be receiving a background, or rather a context that it could be. It doesn't have to be a background. Again, remember, context, the way it works is that you can pass down depending on the different layers that you have for passing down context propagation, for error handling, or rather for passing down cancellation and those kind of things. So we have an exec context, and we're going to be insert into user name, birth year, values. We can call them Wario and 1901. We close this and we quote it, and what is happening here in exec context is that it's going to be returning a result, and result indicates if or how many rows were inserted, the IDs if any of those insertions, they're returning an ID, and that depends on the driver actually, and an error. So we have a result error, and we can do it again. Your typical, we can, oopsie, if error is different than nil, what the heck, use close exit db.ExecContext error return, and then result includes what I was mentioning, the last inserted ID and how many rows were affected. In this case, we don't really care too much about this, so we're going to be changing this a little bit to be like that. So we are executing it. If we run this again, let me open my Docker exec. So again, you have select from users, and we still have the one that we added manually before. If I run this command, you will notice that now I have 2 users. All right, so everything, again, nothing overly complicated. If we go and take this, one thing that you need to consider when dealing with insertions, and typically these values are going to be coming from your users, and specifically when you're doing something that is a write operation like updates or inserts, you need to you will be receiving the values from your customers, like I said, but instead of using some sort of string manipulation, you have to use placeholders. And I covered this in a video regarding SQL injection, and I highly encourage you that you watch that one as well. The way placeholders work in Postgres specifically is by using a sequential $sign placeholder that indicates the values that you're going to be passing in your argument. And let me change this a little bit so it's much more clearer. So what is going to happen here is that, remember, all of these arguments that I have, all of the methods that I'm showing you in ExecContext, QueryRowContext, and QueryContext, not only receive a query string but also arguments, and those arguments are what we are going to be trying to replace as the placeholders. Okay, so in this case there are 2 arguments. We have 1 and 2, which will be equivalent to birth year and name respectively. So name, let's call it, again, let's try a different one, will be Wario 2, and birth year will be, let's say, now 3. All right, so what is going to happen, we can pass in those values now as the arguments that we indicated before in the documentation. that is right here. So we have args will be a variadic collection of arguments that, like I have right here, that's how it's indicated. Now, if I run this again, what is going to happen is that, why is this complaining? Oh, I know. Okay, so we have an error. We close this and we can run it again. What is going to happen now is that now I inserted another record. If I run this again, I now have another record. Now this is again called placeholders. That is really important, and it doesn't only apply to when you're making or doing write operations. It also applies to when you're doing selects and whatnot. Again, it depends of your relational database, and not all the commands are available or support placeholders. So that's something that you need to check out in your database when you're working with specific engines and whatnot. So next one, we're going to be getting rid of this because we don't want to duplicate values. We are going to be doing the last one, which will be query context. And query context, similarly to previous arguments, receives as context, and also allows you to indicate what fields, or rather the query that you want to do, which will be birth year from the table, from users, and it returns rows and error. And this is a little bit different to query row context that we have above here, because this one only returns one, or is expected to return at most one, and this one is expected to return more than one, whatever is found. So we're going to be selecting name and birth year forms from users. And if you run this in the terminal, it will be sort of like similar to what you see on the screen, but we're going to be using another API that it comes in Go. Now, where obviously if there's an error, and I know this is getting repetitive and you're thinking, hey, is there any better way to do this? And yes, it is, and I will cover that in future episodes, so stay with me. Now, rows has an error function or method in this specific case. So if error is different than nil, well, there was another error, and you need to just fail and move on. Because rows is sort of like iterator, is using sort of like an iterator pattern. One of the things that we have to do is we actually have to close the rows after we are done using them. So there's a function called close that you have to call typically in a defer after everything is working. So like I said, there is an iterator in rows, and you have to take and use a for loop. There are a few methods that are in this type. One of them will be next. And next, as you may imagine, it just returns true when there are more values that you can read from. And next is used in conjunction with another function called scan, which is similar to the scan that we use in the query row context method. Let me show you. So we have row next. If next is true, it will keep going. And we're going to be doing something similar that we did before. So we're going to define a bar birthday, bar birth year. That actually we don't have to redefine this birth year, but for the sake of defining it inside the block of the for. And next we have to use a row scan that will take the values from the result that is coming from the database and assign those to the values that we have in Go. And as you may imagine, there is also another check for checking error handling with the rows scan error, and if there is an error, you scan. And finally we're going to just print out the values name, birth year, and last one, birth year. And with that, if we compile it, you will see everything is success. And if we run it, you will see all the fields that we use access previously with our PSQL, which is our command line. So how cool is this? I know, I get it that all of these accessing the basic things are where there's so much boilerplate, but I promise you in future episodes what we're going to be doing is taking what we understood and what we learned before, and making sure that everything that we are using right here will be made easier when you have a better way and a better tools for accessing the database in a much more easier way, either with auto-generated code or maybe some sort of a behind-the-scenes mapping between the fields, the types, and the columns into the database, and also your typical ORMs. So again, thank you for watching, and if you're still here, write in the comments PGX or let me know what database you want to see in the next episode. I will talk to you next time. Take care. See ya.